Good afternoon. This is the second session of the afternoon. And now we have a 45 minutes talk, including questions. And Alex Martelli will answer the question, permission or forgiveness. I don't think I have to introduce Alex. All yours.
Hello, everybody. So during the course of the talk, I will not stop to take questions. They all come at the end. But to help me judge how much time to reserve for question at the end, if you have some questions, or even better, some answers, or even better, some anecdote which either confirms or denies what I'm talking about, please wave, so I can kind of get a sense of how many questions there might be for what is normally a 5-minute space, but I can end a bit earlier and leave more space for question if need be. So, permission or forgiveness is a question, and this talk isn't really an answer. It's a series of consideration. But first of all, let's start with an answer that's often valid and ignored: neither. Sometimes you do something that's controversial, but you do not necessarily have to ask for permission, nor do you have to ask for forgiveness if you think what you do is right. No matter how many critics you get, you can stand your ground. I've been often criticized because for the last many years, my presentations have used a certain proportional font. And some of the critics have smeared my good name on the internet, which, as we know, are a perfect tool for that, by claiming I was using Comic Sans. Please. What I'm using is not Comic Sans, it is not Microsoft Comic Sans, it's Apple's chalkboard. If any of you cannot see the difference between this font and this font, I am really sorry for you. If you can see the difference and still think Apple's designer perpetrated a monumental error in taste, take it up with Cupertino. I don't work for Apple. I am just a happy customer of some of their products. So, the point is, just because what you do attracts a lot of criticism doesn't mean you should have asked permission, and doesn't necessarily mean, consider the critics, they're precious resource. But they could be wrong, sometimes they are. And it's important to stand your ground when you're convinced you're right. So, first of all, sometimes the answer to that question is neither. But the reason the question is asked in the first place is, of course, the famous quote, "It's easier to ask forgiveness than permission," by Rear Admiral Grace Murray Hopper. Let's try and understand better who she was, because it's my #1 candidate for most amazing woman, possibly most amazing person in computer science in a very crowded field at the top, because our field is full of very interesting people, and in particular, very interesting women. Okay. We know, it's easy to find in any capsule list of naval officers, that she had a PhD in mathematics at Yale. That doesn't tell us so much, but it's not hard at all to find much more useful information. What did she do? Well, she, for example, after teaching at Vassar and Yale for a while, managed to join the armed forces, the Navy in particular, but not before having worked on the Mark I, by some accounts the first stored program computers, although having essentially invented compilers and written the first one, we'll come to that, having worked in the committee that defined the common business-oriented language that we know as COBOL. Some would count that against her, but I suspect that's one case where she, if she was still with us, would ask for neither forgiveness nor permission. The term debugging is apparently due to her, or at least some have credited it to her. She was named at the very first DPMA conference in '69, having instituted a new title, which, that tells you how long ago it was the Computer Science Man of the Year, and she won the first such title. other firsts to her name. She was the first ever American citizen and the first ever woman to be named a distinguished fellow in the British Computer Society. She got a Defense Distinguished Service Medal, the highest honor you can have without actual combat experience, and a National Medal of Technology. Some of her achievements and honors are better summarized colorfully. For example, here she's holding up what can be seen as either a nanosecond or a microsecond. It's a roll of copper wire. She salvaged some old machine. It is about 30 centimeters when rolled up in length, so that measures a nanosecond in terms of how far would light travel in a nanosecond, while the whole length of loop is about 1,000 times as much, so it measures a microsecond. This is what she used to illustrate why computers must be small. To be fast, if you want a response time of a few nanoseconds, you only have a few feet in length that light in a vacuum could travel. This is from the Smithsonian Museum, the moth she found and isolated and taped to a lab note inside the Mark I, which was disturbing the circuitry. Presumably the moth was already fried when found, and she claimed it was the first computer bug actually ever found. Of course, that means the term was already in use, but she was illustrating it colorfully. And these are the shield and a photograph of the ship named after her. It's a ship that's seen quite some service in recent years, and they normally don't name ships after rear admirals. You need to be a full admiral. She didn't quite make it full admiral, partly I guess because of her own attitude, but she has a ship named after her. And it's, at the time at least, it was only one of two ships named after women who served in the Navy. So, what did she mean when she said it's easier to ask forgiveness than permission? Reading it in proper context, she was essentially referring to creating innovation while working inside a bureaucratic organization. Of course, the main bureaucratic organization she worked on and off for her life was the Navy. She spent decades there. But she also worked in private industry, and whenever she was working with large firms or committees or volunteers, open source wasn't really around at the time, but I suspect a sufficiently substantial open source project with dozens of committers ready to shoot down any new proposal, any real innovation and so on, would also have qualified. And so I think it's much more general than, okay, if I ever enroll in the Navy, I'll keep that in mind. It's not just the Navy. It's essentially any organization that's substantial enough. And you could sensibly wonder, but does it work? Am I going to get court-martialed or something? Well, she lived her whole life by this principle, and her amazing track record of innovation, the way that she was promoted without ever seeing any combat action all the way to Commodore, the name Rear Admiral was a later rename of the same rank, and the amount of other honors and recognition showered on her proved, at least if you have the kind of brain she obviously was blessed with, it can work. Some example of where she actually applied this principle, and actually in one case debated with it. Well, first in that little corner there is an example of what she did at, I believe, the age of 7. She dismantled her alarm clock to see how it worked. Of course, it was a mechanical one, so she stood a chance. Putting it back together didn't really work, so presumably eventually she had to apologize to her mother, who needed to buy another alarm clock, but she just went ahead, because if she'd asked her mom, "Mom, can I please dismantle my alarm clock?" You know, it's very unlikely that the question would have been answered in the positive, and then if she went ahead and did it anyway after having been forbidden, that would have been more serious. So she just didn't ask. She just went ahead and did it. So presumably the punishment wasn't too horrible since she kept doing those sort of things. Another major example. She actually had tried to get permission, as in some funding, some personnel at UNIVAC, to work on this concept she had whereby you'd write some sort of structured English and a magical program would turn it into executable machine code, and everybody said, "You gotta be crazy. So take the rest of the day off, go and rest a bit. You're obviously not doing well." So at some point she said, "What the hey?" and just went ahead and single-handedly coded the first compiler in the history of mankind, 1952. And her example, besides the fact that people couldn't believe there wasn't, like, the Mechanical Turk, somebody hiding behind the machine and actually inputting the needed machine code on the fly, she eventually convinced the world that, yes, she had a way to translate, and there were so more generally way to do something so beyond arithmetic as to translate structured English, as she called it at the time, into executable code. Note that her first follower, the first research group that went ahead and did the same thing, had the marketing smarts to name their construct formula translator, because the concept that you can translate a formula is easier to accept than the concept that you can translate structured natural language, which is what she was really about. And that, of course, they were at IBM Research, and IBM has always had a slightly higher skill at marketing. Other examples, she later in her life got very interested in microcomputers, which she thought would essentially replace the mainframes that were still the dominating paradigms. And what she wanted to do was get people from ideally all over the armed services at first, but at least from all over the Navy, who were interested in working on similar systems, get them together to exchange ideas. And of course, she couldn't get any permission or funding for such a concept. Who cares about those tiny things? We need really powerful computers. You know, we're the US Navy. We need power. We have power. And so she just went ahead and organized it anyway. The way she managed to get enlisted personnel to actually get the time to join her in Bethesda is a story of itself. And this is, the conference was, of course, finally acknowledged after 2 years of rousing success. And also she felt badly for the hundreds of others who just couldn't make it to the conference. So she wanted to publish a journal, a newsletter, a magazine for them. And apparently, that was something you just don't do in the Navy or the armed forces in general. So, of course, what she did was she went ahead anyway and published it. This is a memorial copy many years after, and it's now, or if it's still being published, I'm not sure, titled Chips. But the original title was actually Chips Ahoy. Don't know if you're familiar. They did eventually get permission from Nabisco Brands, I believe, is the owner of that particular trademark. So, why does it work? Okay, so why don't you necessarily get court-martialed and shot, but rather showered with honors if your unauthorized initiatives work? Well, put yourself in a bureaucrat's shoe. Maybe your title is not bureaucrat, it's a middle manager in some organization. That means your job is to reject things. Listen to all the bright ideas which come, usually from young people in your organization, sometimes from the outside, sometimes from, not everybody grows old when they grow up, so it's not necessarily an age-related issue. Listen carefully, not and say, no, this can't possibly work, or this is not aligned with the strategic objectives, or you can, if you do get to be a middle manager, they give you the secret manual of sentences you can use to say no way in less offensive ways. And not only is this the middle manager's job, it's also a good incentive, because saying yes make everything much more complicated. And if you give the permission and a lot of money gets burned or wasted and nothing works, your next promotion can be at risk. Well, if you just said no, nobody's going to notice that you just rejected the innovative concept of the telephone, because, well, in the case of the telephone, that was documented because the proposal came from somebody outside of Western Union. But assuming the innovator goes away anyway and working under the radar manages to pull off a life-changing, world-changing innovation, then what becomes now of the bureaucrats' incentives, the middle managers' incentives? First, if it's a rousing success, possibly nobody will ever bring it up, or even noticing that the bright result came from somebody who reports to this person, that person will get a gold star, metaphorically, at some level. So, of course, they'll keep their mouth shut. Even if it doesn't work too well and the time the innovator wasted, so to speak, although it's an important learning experience on a failed project, means the other project didn't advance as much as it should have, it's much easier, less work, less complicated, less risky career-wise for the middle manager to say, don't ever do this again, and then go on board. Of course, if it is successful, so much the better, but even for a reasonably sized failure, if nothing has exploded or nothing had exploded with a too loud a bang, it still kind of works that way. Does this concept have any application beyond the realm of operating within bureaucratic organization? If it only applied to working with or alongside or inside a bureaucratic organization, it would already be pretty precious, because none of us, unless maybe we become hermits and go live on a very solitary mountaintop, can really do without interacting with many big organizations. Maybe we're not part of them, but that doesn't mean we can just avoid them easily. I believe it does. Several other fields with just a little extension of the concept can benefit from applying it. And of course, given this conference, the first one I'll be talking about is Python, but there are many others, as you will see. I was actually a bit flabbergasted researching this search that the Wikipedia entry on Maurice Grace Hopper credits me for applying these terms to Python in my nutshell book. I'm pretty sure I was quoting somebody, but honestly, I couldn't really tell you whom I was quoting. I mean, besides Grace Hopper. And then, very importantly, to give a little bit of contrast, we'll consider when doesn't it work. And I essentially claim there's two important cases: when there are sensible rules and principles in place, or when it breaks Kant's categorical imperative. Nothing that breaks the categorical imperative can possibly be right by definition, but we'll get to that. So, how does it apply to Python? I imagine you're pretty familiar with the idea, but this is a function trying to read a file by asking permission. It checks that the file in question can be accessed for reading, and if so, it opens it and returns its contents. And if the check, the request permission to open the file for reading fails, then it returns the default. Well, this code is so bad that it's now given as a bad example to not follow in the online Python docs. I don't know if you've read, as opposed to like looked up a specific function or something, the online Python docs recently. They keep getting better and better, and that's thanks to all of you and a lot of people in this room who keep submitting improvements. And most of the submissions are very good and get happily accepted, so remember, send in your suggested changes to the docs. But it's already pretty awesome, as I say. So, I'm going to just name a few. There's probably other processes running on the same machine, or the file path might be on a remote. It could perfectly well be that when you ask whether, can I access this file for reading, the answer is yes, sir. And by the time you actually go ahead and open it for reading, the answer has changed. And it's, nope, you can't anymore. Maybe the network has just gone down, maybe somebody else has deleted the file. So it's, you're really opening yourself to a race condition here, and you can't really protect against that because you don't even know who you're racing against. Maybe just somebody who's going to stumble in the network cable if you're still using a cabled network. That does not very useful. So what should you do instead, according to the online docs, and I agree, just try, go ahead and do it, and ask forgiveness, that is, catch the exception, in Python terms, if it doesn't work. So just try to open it, and if that gives you an IO error, then you know, whoops, you couldn't open it for whatever reason. Maybe the file isn't there, maybe it's there but you didn't have permission, don't really care, just return the default. Otherwise, then you can return its contents. There's some difference. Somebody will usually at this point raise the objection, wait a second, but this one is using the effective UID, the first one was using the real UID. Well, if you're running set user ID scripts, you have other problems already. So that's being all nice and precise and using OS access is not really going to help that much. So, another permission or forgiveness question. There used to be a very similar choice. In Python, you were not supposed to do type checking. Yes, we always had an isInstance function, but it wasn't considered good style. It's got different problem, of course, as in nobody's presumably going to change the type of X under your nose, but completely different problem. X could be a decimal, in which case doing a +1 on it would be fine, or any other kind of number, including some user-coded class, and doing a great job emulating a number. The alternative has always been the duck typing. Just try to do the x+1. If it doesn't work, you'll get a type error, and then you return the default. And this is duck typing, which I always prefer to illustrate with a drawing of a duck actually typing on an old-style typewriter, but it's just... this used to be the case until abstract-based classes were introduced. Now, they checking whether X is an instance, not of any specific type of number, mind you, just of the abstract class number is considered just fine, because all of the existing numbers do belong here, and if somebody goes ahead and invents and implements their own number implementation, they're of course supposed to register with the abstract number class, and if they don't, it can be done in the application code at some point. So this now applies, but only for the relatively few type classes which are supported in collections and numbers. Most cases, like a file-like object, really remains a concept better dealt with duck typing. But if it's about it being a number or being a sequence or being a mapping, this is now the more suggested way. So if you find yourself in this kind of situation, should you write a new abstract-based class with this type class functionality? I'm using borrowing the type class term from Haskell because apart from the fact that things happen at runtime instead of compile time, it's really pretty similar. It kind of defines which operations can be applied to an instance of any class belonging to this type class. I think normally no, but if you're capturing some well-known, well-recognized abstraction, you're doing a framework or library for dealing with polygons or images or sounds and so on, then it might be quite useful to have some abstract way to define, okay, but is this thing a sound or an image or something like that, especially if there can be multiple implementations, which of course there can be for any of the thing I mentioned, like some sounds might be a bit of memory, others might be a pointer to a file on disk in different formats, so you really want this kind of flexibility. You should only do this for stuff that really matters. That is, if you're doing a multimedia-focused framework, then images and sound should probably be there, but polygons don't seem to have much to do with your framework's nature, so don't impose them on a mind load about them to the user. And, of course, the best time to write an abstract base class, even though its first purpose may be to be an abstract type class, is to offer useful default implementations of some methods. Pure interfaces may be okay. I'm always a bit dubious. Okay, so this thing isn't defining any default semantics for all of these methods. Is that right? Sometimes it is, but be very critical about that. Be particularly careful. I keep repeating this concept every time some new big thing, and this isn't new by now anymore, but it's still new to some, gets introduced in Python. Just because there is this new, incredibly cool hammer does not necessarily transform all problems into nails. The screws are still best dealt with a screwdriver, and so on and so forth. So, in programming, when is it good to go with the easier to get forgiveness than permission? First, you need to be able to easily detect if something has gone wrong. Because if you do not, if the operation is not correct, you must be able to know. Normally in Python that would mean catch some exception. There could be other examples. And this is an example of what in the startup field, or in particularly in enlightened non-startup companies, is known as fail, but fail fast. It's okay to fail, but not to take 3 years working on something and then acknowledge that you just wasted 3 years of your life. That's a lot of time. If the operation that failed in the middle did some partial work, alterations to the program state or something, it must be pretty easy to undo it, or in case the problem was with 2 changes happening at the same time, we'll see examples later, reconcile the conflicts. And this is the example of something that's particularly crucial in the startup world: fail, but fail cheap. It's okay to try something that doesn't work, but not to spend $1 million you don't have in the process. The best situation is when failure is relatively rare, because normally the detection that there has been a failure and the remedy of it, or especially the reconciliation of like multiple conflicting changes, can be, even when they can be done, are hardly ever fast. I'm overgeneralizing, but then I don't want to spend an hour on this one slide. So be careful. If maybe you could spend a nanosecond checking something, just like about this big space, about a foot, or you could try anyway, but if it fails, it'll take a microsecond to find out it failed and fix everything up. Well, simple arithmetic tells you you'd really like the failure probability to be less than 1 in 1,000. If it fails every 10th time, then you're taking a long time if the checking could have been done very, very, very fast. On a side note, sometimes neither permission nor forgiveness are appropriate, and I take here as the example getting a default directly. So if instead of saying if hasater x foo, or even this would be the easier to ask for, this would be the ask for permission, or use x.foo and catch the attribute error, which would be the ask for forgiveness, get after of foo with a default of bar can be the smoothest, most readable way to go. And similarly for dictionaries, you could do a d.get, providing a default. So instead of either just trying to index and catching the exception or checking if the key is in the dictionary. When you can have a built-in default, which is a try, but if the semantics are already in a single line, try, but if it doesn't work, then do this, then that is, of course, the most feasible approach. So, if it's such a good concept, is it exclusive to Python, or can we expect to see it in other areas of software? Well, of course, there's plenty of excellent examples in other areas of software. And my favorite example would be optimistic concurrency, as opposed to traditional permission approach based on locks and mutual exclusions and so on. It's relatively modern, it can be very speedy, as long as the rare transactions that cause conflicts get detected and can be retried easily. This is going to be very good. For example, an example completely outside of the area of database of optimistic concurrency is how should you do source code control? Well, the most dominant paradigm once was, okay, so I know I need to modify these files, so I lock them, and now nobody else in the whole company can modify them at the same time. I do my modifications, and I commit the changes so everybody can change them again. That was, I don't know how many of you have lived through those real hell, especially if you originally only got one, and then say, oh, I also need to modify that. Whoops, somebody else has gotten that and is waiting for you to freeze, so you ended up in deadlock. It happened. The modern way, it's not even that modern, it's decades, is the forgiveness way. You do everything locally, and then you try to commit. If that conflicts with some changes somebody else has done, then you're on the hook for resolving the conflict. It's still much better. It goes well beyond software. Take networks. They wasn't exactly that traditional, but one approach to networking would be, well, we can't afford to have two nodes putting signals on the wire at the same time. There would be conflict. So the idea of the token ring. Only one at a time can speak. The token keeps going around. If you don't have anything to say, you just pass it on. That seemed well designed, but this war has been decisively won by Ethernet, more generally, collision detection. Just try speaking. If nobody else is already speaking right now, just try speaking. Just detect that there's been interference, and in this case, back off, and retry later at a random time. Again, most of the time you will not be in conflict, except like when the network is so terribly saturated that it degenerates. Well beyond technical issues, consider how should a company approach the important step of launching a new product. Well, a lot of companies are permission-inspired. They do studies, top-down analysis, they run focus group, they want to find out what the consumers really want, and finally the big launch, maybe after a year or two of preliminary studies, and maybe what the consumers thought they wanted wasn't what they really wanted, or just launch and iterate. Just get the real-world feedback and answer it as fast as you can. Fail, but fail fast. Now, this product is beyond fixing. Have the humbleness, recognize it, just go. Depends, of course, of how pricey has it been to develop and launch an early iteration of the product, but in software, it's not normally all that costly. So, it's a panacea. No, it's not. There are situations where you're better off doing something else. Sometimes you're lucky enough to be working in a structure where there are appropriate rules and principles and appropriate processes to work with them. One example is organization could demand that anything that goes out to any modification or product architecture or so on that goes on to the public be vetted by security experts. Now, hardly anybody loves security experts because they have this way to pinpoint incredibly thin failings in your brilliant ideas, but they're really important. You can't really retrofit security very easily in something that was designed insecurely. to start with. And unless you are one of the few real security gurus, you're not paranoid enough to see where you needed changing. So to work with the system may sound too mainstream, but sometimes when the procedures in place are well justified and reasonable, it can really be a good idea. And last but not least, it's not a good idea in a lot of common, ordinary human interaction. And I think Kant put it best in the Grundlagen. I am not translating the title because whether it means beginnings or foundations or a grounding for, I don't know enough German to base it. But whatever it means, the foundations of the metaphysics of ethics, always act in such a way that you treat humanity, whether in yourself or in other people, at the same time as an end, the reason you're acting. Never just as a means to attain your real end. Because that's just wrong. And I recommend strongly reading Kant or any good English translation because it makes a very powerful case for it. So, for example, I'm trying to find a relatively uncontroversial one, I hope it is. So you want to graduate, but just your thesis isn't working. Well, don't just reach out maybe on the internet or whatever and copy that of somebody else thinking you'll probably get away with it and hey, worst case, you'll apologize. It's not about whether you can get away with it. It's just wrong. It doesn't mean you can't take great ideas from others, but you always attribute them appropriately. That's, at least in most places, that's what you're supposed to do. And that's my talk, which leads us.
Still time for questions? All right. I have a question or a comment. I noticed on your slide 14 where you were talking about failure and recovery from failure. That's also a really good way to design a UI for your users. You should extend this to be available to your users so that they can just try something, and if it doesn't work, they haven't completely screwed up their entire system or whatever it is that they're doing. So it's something to think about when you are designing something for other people as well.
Always have an undo-redo mechanism. Think about it from the start. It's one of those things that are possible but very hard to plug in afterwards. Design with the start, okay, this is going to interact with users, they will need undo, redo, and say commit when they're totally convinced it's right.
So another possible use of this model might be in continuous integration, where you have the choice of sort of asking permission to be able to commit to master or to trunk or something like that, and having to prove that the test passed before you do that, or begging forgiveness and pushing something that you think is right and through whatever means. And if it's not, you beg forgiveness, you fix the tree. The choice is made by a lot of different organizations in different ways.
It's fair, and with distributed version control systems, the ease of using the forgiveness mechanism, I mean, you have your change, it's there, people can test it, it's not necessarily yet accepted into whatever is recognized as the master branch, but it can be, and you don't have to necessarily explicitly submit it. If everybody in the community loves it, they'll pester the keeper of the master to put it in already. Any other questions?
No more questions? Okay. Thank you very much for your very interesting talk.